So today I'd like to talk about a pretty strong part of the story of the National Battery Strategy, which was released in May this year, which is essentially, can Australia be a battery active materials powerhouse? And this is the subject of a report which we're currently finalising for release early next year. The central thesis that I'd like to share is that Australia is one of the richest mining nations on earth with all the battery materials that you would ever need, minerals that you would ever need. We need to do more to move downstream in order to take advantage of our natural advantage, so to speak. So let's walk through this and let's try and understand why this would be something we should be doing. So let's start with this. So this is a plot that was in Tesla put together a few years ago, where they tried to tot up what the demand for batteries would be in the years ahead. And then this was then later published in Bloomberg BNEF. But the takeaway message here is that there's a demand for at least 20 terawatt hours of energy storage. That's 20 terawatt hours. This is a ginormous number of batteries. And you'll see here that the driver for all of this is transportation. Batteries for electric vehicles, passenger electric vehicles. And if you think about that, most batteries are between 70 and 90 kilowatt hours of energy stored. So there's a lot of batteries that have to be manufactured to meet this demand. In this plot, I am absolutely agnostic to the chemistry. I really couldn't give a unit of fat rat's tinkers what you make. But the point here is that you're going to need a lot of different battery metals to turn into active materials to actually satisfy this need. As we know, Australia is a world-leading mining nation, and we have all the battery metals that you need to actually solve this problem. But the challenge here is if we're going to make batteries with nickel manganese cobalt oxide, nickel cobalt aluminium oxide, stuff that you find in Teslas, lithium iron phosphate, lithium manganese iron phosphate, graphite, silicon, all of that, we need to mine more. And Benchmark Minerals Intelligence estimates that we need over 400 new mines. This is a huge number, 400 new mines. Now, if anyone's familiar with how quick or slow it is to actually establish mining in this country, or even any country around the world, it's about 10 years, 10 to 12 years to actually establish mining. And that's all your permitting process, capital investment, all the box and dice that you need to actually get started. And we had this horrible thing called COVID, and this has absolutely impacted this to the point that we're expecting to have quite significant shortfalls in the key minerals that we need to actually support the energy transition around 26, 27. And this is going to have significant flow-on impacts in terms of prices, availability, and so on and so forth. But the opportunity is here for Australia, here and now, for us to move forward to actually potentially capture some of this market. So let's just look at the Australian demand. The Australian demand itself, and this is from the Australian Energy Market Operator, every 2 years they put out the Integrated Systems Plan. It's a freely available document where you can go and look in there about all the different sorts of generation and storage that we need. And they've put now a much bigger emphasis on storage due to the high penetration of solar in our grid. And you might have read recently, there was an article in the ABC talking about the levels of curtailment we're seeing with home rooftop solar, simply because we don't have enough storage in the system to be able to maximize and take advantage of that. And this problem's only going to get worse. Just so we're clear, this problem is going to get worse. So in this plot, you'll see this is broken up on their website into a range of different storage technologies, but the two I want you to focus on is the blue band in the middle and the little green band at the top. And the little green band at the top is what we call a passive consumer energy resource. This is a battery that's not connected to the grid. So this is somebody living out back at Burke, just got his battery storage with his and her battery storage with solar panels, and they're just self-sufficient. The stuff in the middle is the blue, that's the coordinated energy response. This is where we're bringing together home storage batteries, industrial commercial storage batteries, and potentially vehicle to grid or vehicle to load opportunities where we can coordinate this within the grid. And when we think about it, a home storage battery is between 10 and 13 kilowatt hours of storage. If you think about a car, as I mentioned earlier, you've got between 70 and 90 kilowatt hours. So when we think of cars, we should be thinking about mobile energy storage deposits, whereby you can travel in it, but when you get home, you've got actually something where you can either do energy arbitrage, you can run your house, your car, whatever you want to do. There's a real opportunity here, and the energy market operator sees this as a really important piece of the storage story that we see going ahead. We obviously have a whole range of other different storages, and we should be clear that there's massive opportunities for Australia in the development of long duration storage. So remember, most lithium systems are good between 0 and 4 hours. There is the new battery that's being put on in Western Australia that'll do 8-hour storage, lithium, which is pretty bonkers in my view. And then you've got 12-hour storage, and then there's even new markets being considered for 100-hour storage. And these are really important storage mechanisms that we ride through in weather issues and weather changes in order that we can be a truly renewable energy country. So again, here's another reason why we should be thinking about battery and battery materials. So let's think about supply chains and where does all this stuff come from. So this is a really nice paper that was published in Nature Communications early this year, and it basically lays out in graphic detail where everything comes from. And we look pretty good on the left. We've got all the lithium. We've done pretty well in nickel up until recently, but that's absolutely evaporated in recent times due to the production of nickel from Indonesia, which is produced at prices well below anything Australia can produce, and this has literally crashed the price. And you might have read recently that BHP Nickel West has shuttered its Nickel West production facility. You also might have heard that the lithium glut that's coming out of China has meant that some Australian lithium miners are also now shuttering their activities, and they've put them into care and maintenance. So these are significant challenges for us. And why we see that challenge is because as we go further downstream, you'll notice there is one particular red bar that dominates manufacturing. And this is a massive challenge for us. If you want to think of it from left to right, the people on the left are the price takers, the people on the right are the price makers. At the moment, we are a price taker. We are at the bottom end of the curve. We have very little say in price and how we take those prices. And there's an absolute desperate need for us to move this way towards value adding our battery metals and battery materials. I don't have a plot here, but I'd like to also describe to you what a Japanese colleague describes of the battery industry. And he talks about the smile economy. What he talks about there is that battery materials, active materials manufacturers are one side of the smile, cell manufacturers at the bottom of the smile, and then you've got pack assemblers are on the other side of the smile. Being at the cell manufacturing level, it ain't the best place to be because you kind of squeeze between the consumer and the material suppliers on the other end. So there's a big challenge for us in moving this way, but in doing so, there's much that we can gain. But what I'd like to point you to now is this other plot that comes from Benchmark Minerals Intelligence. And I'd like to highlight this statement down at the bottom there. And this is from a couple of years ago, so this is even more depressing now, where they talk about that by 2030, we will only be able to convert 17% of our lithium, raw lithium, to a processed product that may be either lithium hydroxide or lithium carbonate, which is what goes into cathode active materials or into electrolyte materials. We can only convert 17% of what we're going to mine. And you can see here, it's nearly 700,000 tons of material, of lithium carbonate equivalent. It's a huge amount, and we can only convert 17%. And it's probably worse now because Albemarle Tianqi has recently shuttered at least one of their lines and has said they're not going to go ahead building another line. So here's the challenge. How do we move downstream? So I'd like to make the case that in fact, we want to actually move to BAM, and we need to do it pretty quickly. Why? Because actually most of our minerals for batteries actually comes from junior miners. So graphite deposits, for instance, nearly every graphite miner I deal with on a day-to-day basis is a junior miner. So every time they do a piece of work, they have to run off to the ASX to put out a press release to say, guess what, I can do X, and that will see them get a bit of money. And then they'll go back again, I can do this, I can do this. It's not a way that if you're going to build a sustainable, resilient business, that's the way we should be operating. If we want these things, we're going to have to invest heavily to get them. Similar is, and one of the really nice things about graphite, I should also make the point about, is you can vertically integrate on that technology because you only need one input. It's graphite. Because all you got to do is take flake, spheronize, purify, coat, and you've got a final product that can go directly into a battery. And as long as we all remember, every lithium-ion battery, whether it's an LFP battery, an NMC battery, an NCA battery, all requires graphite. So graphite is a really great opportunity for Australia to actually win substantial business. Further, if we think about NMC or LFP, we have all the richness of that we need to achieve. So particularly nickel laterite in Australia is mainly between 1 and 3% nickel, but you'll find about 0.01 to 0.03% cobalt. So we can actually make a product called mixed hydroxide product, a nickel cobalt mix that can then go into an NMC or an NCA type chemistry. And we can produce that in the most sustainable manner as imaginable. And we actually have a partnership with Panasonic Energy, which we announced earlier this year around working with them around similar technologies. And lastly, lithium iron phosphate. Australia is the world's largest supplier of iron. You think we could make some lithium iron phosphate? Yes, we should, and we should be doing these things. Because whilst we know there are plenty of new emerging technologies coming, there is plenty of demand today for the existing technologies, and they're not going to go away. All the big battery manufacturers are invested up until 2040 in their existing plants. 2040. So we have a significant opportunity now to build this capability, and we need to build it fast. Because there's a fellow out of a company called CATL, and he made the statement earlier this year that by 2040, CATL in China will have a mature battery recycling industry such that he believes he will no longer need primary battery materials. Now, if you're a miner in this country, you should be frightened to hell, because they're not going to buy your stuff after that, because they're going to be able to recycle batteries and get everything that they need. So if we're jumping on this train, we need to jump on now. We need to build this capacity. We need to build these industries, because they will provide highly skilled, highly paid jobs, and they will help insulate and make Australian battery industry resilient. And hopefully we'll also support an Australian battery domestic industry, because, as I mentioned earlier, we got 3.8 million homes in Australia with solar panels. 280,000 of them have batteries. There's 3 million homes to still put batteries in. There's a huge opportunity, and we should be trying to solve that problem ourselves.